Started. I'd like to thank everybody who's joining us today for the webinar, 7 Critical Reasons for Kubernetes-Native Backup. I'm Julius, and I'll be moderating today's webinar. We'd like to thank our presenters today, Deepika Dixit, member of technical staff at Kasten, and Mark Severson, member of technical staff at Kasten. A few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a Q&A box down at the bottom of your screen. Please feel free to drop your questions in there and we'll get to as many as we can at the end. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all of your fellow participants and presenters. The recordings and the slides will be posted later today on the CNCF webinar page. With that, I'll hand it over to Deepika and Mark to kick off today's presentation.
Thanks, Julius. So today, we are going to be talking about Kubernetes-Native Backup. So as you know, there's a lot of buzz around Kubernetes today. People are deploying more and more production applications on it, and it has fundamentally changed the way we have to think about data management and protection for these applications. While Kubernetes has helped to reduce a lot of the pain around availability and scalability, those benefits don't extend to your data, leaving backups as one of the most critical, yet often overlooked challenges that Kubernetes operators have to face today. But first, let me introduce who we are. So my name is Mark Severson. I'm a member of technical staff here at Kasten. Previously, I worked as a software engineer and architect at Instructure on cloud education software. And I also worked as a principal engineer at Fetpak Technologies doing public safety software. I'll let Deepika introduce herself.
Hi everyone, I'm Deepika Dixit. I'm here a member of technical staff at Kasten. Previously, I was a software engineer at Tintri, and before that, I got my master's degree in computer science from Arizona State University.
Thanks, Deepika. So first, let's talk about a misconception that people seem to have about Kubernetes. They often ask, is Kubernetes really ready for stateful applications today? It is true that a lot of the early success of Kubernetes was enjoyed around stateless applications. But as time has gone on, especially in recent times, we've seen a huge growth in stateful applications running on Kubernetes. If we take a look at a SysDig report from last year, we can see that half of the top 10 containers running on Kubernetes are stateful. And more than half of the monitored Kubernetes clusters are running stateful sets. So we can conclude that they are running stateful applications as well. And pretty much every storage provider out there today has a Kubernetes driver available. If we take a look at even more recent data from 451 Research and the Voice of the Enterprise, we can see that 55% of organizations that have responded have at least half of their applications running stateful. If you dig into what types of state are used in those containers, in those applications, it's quite a diverse set. We have a lot of traditional relational databases. There are some NoSQL databases, message queues, data and batch streaming. But all of these types of data are data that existed before Kubernetes. So given that, we kind of have to ask, does the old way of managing data still work? Can we still use our VM-centric or our service-centric ways of backing things up? It's our firm belief that the old way doesn't work anymore. Enough of the infrastructure has changed with Kubernetes that it no longer makes sense to think about backups this way. So the first thing I'd like to talk about that has changed is how you deploy an application. Applications are no longer deployed to a single virtual machine. They might be spread across all the nodes in your cluster, in your Kubernetes cluster. Kubernetes is dynamically rescheduling those as needed as load changes. Kubernetes will move those pods around. On top of that, we see CI and CD systems that are constantly redeploying these pods, moving them around even more on top of that dynamic rescheduling. And to add into that mix, we have multi-tenant clusters, so a single application is no longer the only thing running on any given instance. You may have many different applications and tenants running all on the same node. So since we aren't applying the same techniques to deployment, we cannot simply apply the same techniques to backup anymore. So we have to conclude backups need to focus on a complete application instead. Since we can't be focusing on a single instance or database, we have to think about all of the components of the application. We have networking, configuration, service accounts, and secrets, as well as the data. If any one of these components is missing, your application cannot be restored to its original state. Another thing to think about is abstracting away the infrastructure. The newer constructs are to treat Kubernetes clusters as transient or ephemeral. They will sometimes repave a cluster every few weeks for security, and they also move applications a lot. And moving applications allows these clusters to be repaved or upgraded, or as the method of them being repaved or upgraded is becoming much more common. This is the type of portability that is what Kubernetes is known for. We can move across clusters, we can move across environments, or even across cloud providers. This is the type of portability that we want in our data as well. And finally, as we know, Kubernetes has a very rapid release schedule. They release pretty much every 3 months and only support the most recent release plus the 2 previous releases. What this means is that in a period of 9 months, the software running your cluster is likely out of date. Furthermore, with each of these releases typically comes with updated APIs, which means a backup taken of your application just a year ago may not restore properly into an upgraded cluster, at least not without some sort of translation, what we call a transformation. The other great change that we've seen is the rise of DevOps. As we've focused on developers and self-service, it's allowed companies to move faster than ever before. Developers are now able to ask for infrastructure as code, whether that be a load balancer, an ingress, a storage volume, whatever it may be. They're no longer filing a ticket and waiting for these things from their operations teams. Requests like these are now fulfilled within minutes, sometimes even seconds. But unfortunately, this means that the operation folks have been cut out of the loop. They're no longer involved in the creation of a storage volume. So they can't have given any thought to what backup policy needs to be applied to that volume. What this means is there's a greater chance of misconfiguring that storage and losing the data or failing to back up that data entirely. Another area that has changed is scale. Applications are less monolithic than they used to be. Part of this comes from applications being broken down into smaller microservices, smaller pieces. But another part of this comes from these Kubernetes specific resources. These resources allow the application to scale in response to increases or decreases in load. But they also increase the number of moving components in an application, making them more complex. And clusters sometimes need to move these components around as the cluster scales up and scales down. This type of flexibility allows developers to better utilize data services, which is driving some of the explosion that we are seeing in stateful services that are run on Kubernetes. Developers are allowed to choose or have more freedom to choose the data service that specifically fits that component of that application. Another area that we're seeing an explosion in is the number of production clusters that are being run in an organization, production Kubernetes clusters. It's not uncommon for us to see customers running 20 or 30 or sometimes even 50 production Kubernetes clusters. To illustrate this, let's take a look at one of our customers, Soprasteria. They're a very large French IT firm, and this is one of their clusters that we are deployed on. As you can see, they're running OpenShift on AWS, they're running Rook Ceph, and all of this backed by AWS EBS. It's a moderate-sized cluster, about 50 nodes, over 150 applications, and many terabytes of data stored across a large number of volumes. And these aren't simple applications either. On average, these applications have over 100 components each. As you start adding in other production clusters, you can see that the number of objects that you're managing will quickly explode into the hundreds of thousands or even millions of objects. To compound this serviceability that you need for these applications becomes much more difficult. It doesn't scale very easily. You can't service an individual application, let alone all of its components. But in this particular environment, they've done very well. You can see here, they have 2 operations persons supporting over 700 developers. Having a good backup system certainly helps, but you need a good broad set of policies in place to enable this level of self-service for developers. You can't be having developers making synchronous requests out to their operations team. As we touched on earlier, we're seeing a lot of diversity. You can see in this one particular cluster, we have everything from COBOL to Go and Java. And we have a whole myriad of data services. Traditional databases like Postgres and MySQL, even Oracle is in there. We've got MongoDB, Redis, etcd, Cassandra even. There's Kafka and Zookeeper. There's even a Hive cluster running in here. So this diversity we see often. So let's come back to the question from before. Does the old way of managing data still work? Generally, the old way tends to be very infrastructure centric. Looking at the scale of this environment we just talked about, it's easy to see why a traditional backup solution like these would start to fall down. It simply doesn't scale very well. So for example, a VM level backup actually works great for your data. However, your RTOs tend to be very high. Playbooks tend to be very manual. You end up poking through a sea of data volume snapshots to select the set of snapshots that go together to comprise your application. Once you've found that set of snapshots, you can graph that back into your Kubernetes cluster manually and bring your application back online. But once again, that's manual. This tends to be very error prone as a result. Another way that some folks try to solve this is with a quick script. But as you know, a quick script is rarely ever quick. Soprasteria, for example, tried to use AWS Lambda to back up their applications. It works great on day one as it's tailored for your specific application. But it's a lot more complex to maintain, and you have a reduced portability as it tends to rely on infrastructural pieces. Oftentimes this is accidental, but it does happen. And self-service for a quick script like this can be quite a challenge as well. You have to refit that custom solution around every new application that comes online. And finally, if you already have a storage overlay on top of your storage system, you might be inclined to think, you know what, let's just use that for our backups and migrations. But this is kind of the worst of all worlds. You don't get fault isolation. If your storage system dies, it usually takes your backups with it. And it's the lowest common denominator. It has a very high performance cost has security implications. There's really not a lot good to say about a solution like this. We really don't recommend it at all. So before we jump into tackling some of these problems, let's take a look at what customers typically do. They might be running on bare metal. They might be running on virtual machines. They might be running on virtual machines in a public cloud, or they might be using a managed service in a public cloud. What is common to all of these is that they're running Kubernetes on top of that. So it's important that Kubernetes native backup solutions are used in these environments, and that that backup system is built to work with Kubernetes, or with each of these environments, as well as Kubernetes. Kubernetes being a common substrate has actually allowed even a small company like Caston to move cloud providers 4 times already. We've been able to back up and migrate these applications between, or being able to back up these applications and migrate them between cloud providers has been key in allowing us to do these migrations. Generally, these migrations we've been able to do in just a matter of days, moving between cloud providers. So some of these migrations might be kind of a lift and shift for a containerized application. Some application that we had before and have just wrapped a container around. Some might be a newer, more cloud native application, something built as a microservice, or some might be an application that used to be a monolith, but have been broken down into smaller pieces and now are cloud native pieces of an application. So with this kind of gives you an overview of the types of things that are difficult or changed in Kubernetes native backup systems. And with that, I'm going to hand it over to Deepika to take you through the rest of the presentation, as well as a few demos.
Thanks, Mark. Let me just take over. So, okay, I'm online. All right, so like Mark mentioned, sorry.
You're showing your presenter view.
Oh, I am? Oops. Better now? Okay, thank you. Can you see the presenter now? Okay, sorry about that. Okay, so thanks, Mark. We've seen the Kubernetes architecture right here. And as we talk about a cloud native or Kubernetes native backup and solution, we need to think of an application that sits on top of this architecture and integrates correctly. First up, you need a backup solution that uses the Kubernetes API to discover the application and anything that's running on it, like all the underlying components, everything. So it needs to be able to integrate with the Kubernetes solution, irrespective of the distribution. So it should be completely Kubernetes agnostic. Next up is the infrastructure. Since Kubernetes is infrastructure agnostic and we have so many different distributions, you need a solution that has minimal integration with the underlying infrastructure, be it physical or virtual. It should be able to support block, file, or even an object store compatible storage. And it should be able to integrate with more complex solutions like CSI. The third thing, it should have an optional application specific framework that you can plug into. Say you want to run specific commands or run some blueprints or have some system hooks in your system right before you take a backup or while you're doing a recovery. Your backup solution should be able to do all of this and sit on top of your Kubernetes environment and not be and be able to extend it as well. Next up, we're going to move into this demo, and I'm going to use Kind and CSI snapshots for this. So if you're not familiar, Kind is Kubernetes in Docker. It's an easy way to set up your Kubernetes cluster locally so that you can experiment with Kubernetes. And as for CSI, the container storage interface, it's a standard for exposing storage systems so that you can use it for, say, snapshots or other extensions to the Kubernetes ecosystem. So let's go to the terminal. All good? Can see everybody? Okay. So this is a simple Kubernetes cluster that I have running in Kind, and I have a CSI host path driver already installed in here, over here. So for this particular demo, let's look at what we have already in the cluster. So since I have the Kubernetes host path driver already set up, I can get the Kubernetes volume snapshot class. So as I said, CSI host path snapshot class is already present. And if I try to look at what it contains, it's a simple custom resource, which is from the snapshot storage API. So now I'm going to create a snapshot for an application that I have running right here. So let's apply the volume snapshot YAML, which I have right here. So now I have a volume snapshot created. If you want to look at this YAML for a second, it's a custom resource of the type volume snapshot, and it's taking a volume snapshot of my persistent volume that I have, CSI PVC. So now that I have already created the YAML and the volume snapshot is created, I can go and fetch this volume snapshot. As you can see, a volume snapshot, new snapshot demo has been created for my source PVC, the CSI PVC. Now, if I try to describe the volume snapshot as well, you can see that the snapshot controller kicked in and it has created a volume snapshot for this PVC. After I've already created the snapshot, let's try to restore it. So if I look at my restore YAML, you can see that I am creating a new persistent volume claim. And the data source here is the volume snapshot that we have just created. So the volume snapshot, new snapshot demo is being used as a data source for this new PVC. So the volume PVC got restored, and I can do a kubectl get PVC to check on it. So as you can see, this was my original CSI PVC, and with a volume snapshot, I have created a new CSI PVC right here, which is within this new name. So this is a very simple CSI example that I have running right in my cluster. If you want to explore more, this is an open source project that you can go and look at and run these examples yourself. Okay, back here. Apart from the management concerns that Mark mentioned, there are some other things that you need to look out for, especially when you're dealing with Kubernetes and your stateful applications. First up is security, obviously, with Kubernetes being architected specifically for fault tolerance, which by the way is great. It gives us high availability and replication, but all of that is still not a backup. With malware and ransomware being targeted towards Kubernetes, it is very easy to lose data and have data corruption that can replicate quickly throughout your cluster and have catastrophic effects. Kubernetes itself does include several security features that can help with mitigation. Like for example, you have network policies, so you can deny access to say internal application components, as well as any untrusted services outside your cluster. So how do you define a backup and recovery solution in such a scenario? You cannot have something sitting outside the cluster trying to monitor the cluster if it cannot access it. And you don't want to change your network policies or weaken your general security of your cluster just to be able to take a backup or restore. You cannot manage your data protection. You cannot have your data management solution having you to compromise on your whole system. So you need a solution that understands this and helps you navigate while also keeping your network and security policies in place. Kubernetes also allows for multi-tenancy with the use of tokens and role-based access control. You can have multiple tenants and each of them could have different tokens accessing different parts of the same cluster while being completely isolated with each other. Each tenant runs in its own sandbox and doesn't need to know about any of the other users. So a backup solution that not only understands this, but takes advantage of this is what's needed. Kubernetes also has ways to add encryption as well as quick recovery, and a backup solution that understands and adds on top of this is needed. Apart from security, we also need to consider about the ecosystem integrations. We've seen that with Kubernetes, we have a lot of integrated services, which are not limited to just the databases, but also other systems and other integrations, other system hooks, etc. The whole ecosystem, like we've described before, now includes everybody. It includes developers, it includes the IT, the ops, the database admins, as well as the storage admins. A solution that is completely cloud native and understands this ecosystem will only enhance the ease of Kubernetes and be able to harness everything that it has to offer. It could include integrations with Prometheus for monitoring or any alerting system, or even Kubernetes APIs or custom resources for, say, RBAC, any logging, or any other modifications or extensions that need to be done. Lastly, the main benefit of Kubernetes is the portability. You don't want to be tied down. You need to have the freedom of choice when you're selecting your infrastructure, or whether it is on-prem or in the cloud, or even if a hybrid system. You should be able to use whatever storage system you want without having to change your data management strategy. The data management solution itself should not have deep hooks down in your system or even your storage layer, such that you cannot migrate or move to a different storage solution or even a different version of Kubernetes. You should be able to move, migrate, switch between different configurations whenever you please without sacrificing your data management. Now that we've discussed all this, we want to give a quick demo of another project that we have. So this project that we have is our open source project Canister. You can go and check it out yourself. It's completely open source. You can look at the examples. So for this, what we're going to do is I have a simple application running in the same cluster, which is my demo app right here. And what I'm going to demonstrate is that when sometimes snapshot is not enough, you need a backup of your system. So with Canister, what we're going to do is we're going to take a generic volume snapshot, and we're also going to use that data, back it up to S3. So just to make things easier, I have the commands right here. So I'm just going to play with them. So right now I have, I have this one pod running right here, which is a demo app, a simple application. And I'm going to create a document that I put in this application. So this is a test file. Let's see if that works. And I have this application right here. So I'm going to copy this data into the pod just to demonstrate a snapshot and recovery. So let's use this pod. So just copying over the data right here, and I can check if the data got copied by just doing an exec. So I'm going to do that right now. So as you can see, we have one file right here, test data. So now to take a snapshot, just to make things quick and easy, we're going to use the dashboard. Don't worry about it. So I have the application right here, and I'm going to snapshot it. And I'm using an S3 bucket for the backup. So this is going to take some time, but it's using Canister underneath. So it's going to run a Canister volume snapshot for this application and take the backup right here. So it's going to take about 30 seconds to complete. And oh, great, it's done already. So let's go back, and just to confirm that our pod's still here, we have our same pod running right here. And I'm going to remove or delete the data. So mimicking something disastrous happening to your cluster. So remove the file. Now I can go back and try to list it, and there is nothing right here. So the file was deleted. Let's use the UI again, just to do a quick restore. I'm going to initiate a restore, and it's going to take some time. Again, underneath, it's using Canister, completely open source. You can do this through Canister directly, but just to speed things up using the UI right here. So what this is going to do is going to fetch the data that it needs for this restore and push it back into the pod. So once the restore completes, let's go back and see what our pod looked like.
Deepika, while you're waiting there, we
Yes.
have a question.
Yes.
It asks, with host passed, you're putting the host path, if I can speak, you're putting the content on the container itself, then how is that fault tolerant?
Yes, so good question. So with CSI and volume snapshots, it is true that you're putting the data directly in there. So if your system crashes, you lose all your data, which is why we wanted to demonstrate this in the second part of the demo, that sometimes taking just a snapshot, which is in place, is not enough. You need a complete backup of your solution. So you need to understand that a backup solution will not only take a snapshot of your system right in place, but also protect it from issues that could go wrong in your system directly. So it needs to be able to, say, use object storage, for example, to be able to export some of the data out there. I hope that answers your question. Okay, so the restore is complete. So I'm going to come back to my terminal and let's look at the pods that I have. As you can see now, the pod has changed. So what Canister did is it scaled down the system, put the data back in and scaled it up, creating a new pod right here. So now we can look back at the new pod and see if the data that we had from before exists. So I'm going to use this new name right here. And the test data is there, but that's not enough. Let's do an MD5 and confirm that it's the same data. So this is the test data from before. Let's copy the data from the file, from the pod itself into a new file. So the new pod will have something called test data in there. So I'm going to take that up and move it to new test data. And now I'm going to do a MD5 of, and they're the same. So that's just validating that our restore did not mess anything up. So that was a simple example of how you can use Canister to do a backup of your solution, which is not just a snapshot, but also using an S3 bucket, for example, to keep some of your data, the metadata and data related. So summing up, we've seen from the demo as well as some of this talks that we gave right now that just having a backup solution is not enough. You need something that is purpose-built specifically for Kubernetes. And you need to think of a solution that has all the cloud native architecture principles in it. It should be something that's easy to use, install, and extends Kubernetes by a whole. It takes advantage of all the cloud native principles and everything that Kubernetes is popular for. Say, for example, the extensive support cases, the whole application stack, something that Kubernetes gives this freedom of choice, as well as good application mobility, as well as the whole system, giving the application as a whole the importance over just the data or say volume, for example. So I think that's where we're at. And I think we have a few questions. So we can open the floor for questions, I think, now.
Right, so we have a couple of questions here. I will read them as we go. So first up, so Canister backs up only pod volumes, or does it do much more?
It does much more. And I do encourage everybody to go check it out. It has a lot of examples for what all it can do.
There are a lot of hooks in the system that allows it to do custom things for a lot of different types of applications. So it's much more than just pod volumes.
Yes.
All right, next question. So Canister uses CSI snapshots underneath. How does it then access the data to replicate to S3?
Okay, that's a very good question. It does have hooks for the CSI snapshot. It does apply that, but you can also write your custom blueprints that can help with a more data-driven and not just the pod volume snapshot. So if you look at the GitHub page, we have examples that you can plug into, say, MongoDB or even Postgres, stuff like that. So this example that we have took a generic volume snapshot, but you can also fine tune it to not just do that and do much more than that. So in this the second example that I gave, it took a volume snapshot that was not CSI, which is why it was able to port some of the data to S3.
All right. Our next question here, can Canister be automated to take backups and restore? Absolutely. This is what our product K10 does, actually. It automates Canister to run these backups for you. You may have seen Deepika jump through the UI a little bit here and there, and that is our K10 product automating Canister. So absolutely, you can automate Canister. Next, does Canister run as a sidecar or as a controller?
It runs as a controller, but I think there are modifications that you can run it as a sidecar as well. But obviously you should check it out to have more details, and maybe find us on Twitter or something for like a more detailed version of it.
All right. Can Canister take a backup of the entire cluster?
You can run specific blueprints that can span your entire cluster. But the blueprints right now that we have are more application centric. So you could always tweak it. Like, for example, you could have a label that spans your entire cluster with all the applications in it. And that could be an cluster level backup, for example. But just to reiterate, since application itself is the granular unit that we consider when we're taking a backup, it is application level at the core. But you can always tweak it to, include multiple applications, and that could easily be a whole cluster.
Okay. This one I don't know. Deepika, we'll see if you know. How does it compare against Valero?
Oh, okay. That's a big, long slide, I guess. Maybe we should take it offline, not right here. But yeah, short answer, Canister has blueprints that you can do, again, application specific stuff, whereas Valero does not offer that kind of support. So I think because of the customizability and application level, Canister is a little different.
Do you have an option to schedule the snapshots or backups through Canister?
Currently, no, but you could write a quick script that does that because at the core, the blueprints that I've mentioned are custom resources in Kubernetes. So you could easily write some script that runs around it that can make it do that. But if you're looking for like an enterprise version, obviously K10 is what we would suggest.
That actually relates to this next question a little bit. What process or tool do you recommend for an enterprise to move workloads from one cluster to another?
So you can try, well, this is not a commercial talk, so I'm just going to open the slide up, but we should talk offline because that specific use case is handled by K10. And we have a free version, so you can check it out and you can talk to us offline.
Yeah, there is certainly a lot that needs to go into moving enterprise workloads between clusters. Canister is a great start for parts of those pieces or parts of that, but you definitely need more than just that one piece of it. So.
Great.
More questions? Oh, one more. Sorry, I was speed talking earlier, so we have a little more time than we anticipated here.
Yes, me too.
Is it not an anti-pattern to back up content in pods. If a container needs persistency, it needs to use PVC. I think what you're saying is you shouldn't be making a backup into a pod. You need to be using a PVC. Is that?
Yes, yes. And that is what we do. I think maybe I wasn't clear, sorry. But like if you go back to the original, let me just go back to the diagram that Mark had at the beginning, which is an application as a whole does include persistent volume in the pod and everything with it. So the backup by itself should, yes, consist not just the pod data, but everything that's attached to it. So when we talk about an application or a pod, it's an extension of everything that is needed for that application. So that includes all the data in the PVC. And with the canister example with the volume snapshot, what we did was we scaled down the cluster and then attached the PVC with the restore and then scaled it up. So it didn't actually put the data directly in the pod. It did have a PVC attached that did that. So, yeah, sorry, Mark.
And to add to that, we absolutely recommend when you make a backup, those backups should be pushed out into an external store like S3 to persist that data. That certainly helps so that you're not storing all of that data in a pod. All right. Database dumps has been supported via backup. I think the question being asked here is, does Canister support database backups?
Yes, definitely. So Canister with the blueprints, you can have pre and post hooks. So for example, you want to requires the application before, or say have a MySQL dump or a Postgres dump right before you take a backup, all that is supported. We also have some blueprints written on the GitHub page and the examples that do just that. So yes, you could have a MySQL application take a backup via Canister, where one just takes a backup directly, whereas the other one actually does a MySQL dump, quiesces the application, does all of that. So completely extendable, and yes, we support all those use cases.
Specifically what Canister is built for, this is what Canister does well.
Mm-hmm.
Great. Okay, and there's a thing called platform.sh, which does the entire Kubernetes backup and restore. Have you come across it? I have not personally.
Yeah, I haven't either. And I think based on the whole cluster, yes, there are a lot of solutions that do that. And Canister is one other one which does it, and I think does it better at the application level, which is what we think is the operational unit of the whole cluster. So you could have your application move between clusters, or say your application being the primary source of what you want to run as compared to having the whole cluster. So if you have the whole cluster, then you're tied down to have all the applications that were running in that cluster to that backup. And we don't want that. We want to be able to split between applications and technically even users for that matter.
Right. That is one of the core things that we think is difficult in a lot of backup solutions, especially ones when you're coming from the traditional infrastructure centric. They tend to back up entire units and entire VM. You know, you're not getting individual processes or applications on that VM. You're getting the entire VM, and this sounds very similar. You're backing up the entire cluster, just like Deepika is saying. You don't get that granularity and the flexibility to be able to move particular applications around where you might need them. You can only move an entire cluster. All right. And can Canister do incremental backups?
I think we can. That's the short answer. But how is a little, I guess, more detailed version needed later on. You can have hooks that can help you with do that. I'm not sure if we have an example of that right now. But with K10 and Canister, it's definitely doable. So Canister might have some hooks that you might need to play with. to help with that. Is that all?
Okay, that is all of our questions.
Great. Well, thanks, Deepika and Mark, for an awesome presentation. Thank you, everybody, for joining us today. The webinar recording and slides will be online later, and we're looking forward to seeing you at future CNCF webinars. Oh, let's see, there's another.
Oh, there was another.
Well, the recording will be up, on the CNCF webinar webpage later today. Thank you, everybody, and have a great day.
Thanks, everyone.
Thanks, everyone.